Hello, welcome to the webinar, How to Refactor Your Software Architecture. We are going to leave 5 minutes of courtesy to people while they come. So meanwhile, I will tell jokes and funny stories, haha, with my assistant, Little Pig. No, I'm just joking, I'm not going to tell jokes. What we can do is we can go over a few test cases, a few cases of the ones we are going to see later, so I can explain to you a little bit more in detail while we start. So in 2007, I joined a large Spanish bank as a software analyst in this case, and they were in the middle of a huge migration project, which was a mortgage project, and I was in the part of mortgages, so I was somehow my boss was responsible for the whole project. There were like 25 people there, and they were all redoing our mortgage workflow. So it was like, I don't know, at the peak time, it was more than 20 people. They were using some huge workflow software system, which was supposedly much better than the one that we were using at the time. So what we were using was a set of Java services and an Oracle database underneath. So everything was managed with that. And the new system was a huge workflow system. It was awesome. Apparently, we had two very large servers by some vendor, which I cannot name. And in the end, the project failed miserably. After the bank had spent around 2 million euros. So that's one, not a success story, a failure story, but actually you learn a lot from your failures, as you will probably know. And the problem at that point was that the workflow wasn't even able to start. When they hit the start button, it didn't even start. It hung at some point because it didn't work. So we brought in some fancy consultants from New York, and they came here. One of them was a very picturesque character. He was wearing high leather boots, actually snake leather. And he told us that it didn't run because we didn't have a big enough server. And then we said, but these are the servers that you recommended. He said, no, but you need big iron servers. So he meant some Z series servers, which are huge machines that cost many millions of dollars. And in the end, we decided that the project was not going along. So they shut down everything. 20 plus people went away. And it was a funny story. And then I'm going to tell you another case study, which is my current company, Influencity. Hi, Influencity. Where things have gone a little bit better. When I joined, it was a small team of 3 people. Now we are around 7 people. And we are successfully transforming the company from the systems that they used to have to a much more improved system that works much better for us and is much easier to modify. Okay, so we are about to start at the moment with the slides and with the official presentation. So what we are going to talk about is how to refactor your software architecture. Usually when people speak about refactoring, they mean just software, refactoring some bit of code. But we are now speaking about transforming how the company operates. This means changing what software is used. This means changing practices, changing code also, and changing everything. And processes, mainly processes and people. So they are more challenging changes than just refactoring code, which is pretty well known at this point. So first, I am Pinchito on Twitter. I just tweeted this link to the slides if you want to follow along. And I work at Influencity, where we do influencer marketing. This means trying to sell things to millennials using influencers, which are very trendy people with accounts, usually on Instagram. So what are we going to cover? First, we are going to see a fork on the road when you arrive to a new company and you have two ways in front of you. One is keep what is running at the moment and work with it. And the other one is to rewrite everything from scratch. Yeah, many of you are probably familiar with this conflict, with this fork in the road. Then we will see how to improve our running system while it is running, which is quite a challenge. Then how to do live migrations from one kind of system to another. And then we will see in detail a practical case, which is my current company, Influencity, and a few conclusions. Okay, so a fork in the road. You arrive at your new company, congrats, you've been hired, you're the new CTO of the renowned Acme company. And they tell you have to deliver results. You are earning a lot of money for them, probably not enough for you. And as it happens, the old system is a bit slow, it runs to a crawl, it's quite limited, and probably developers do not love working on it as much as they should. So we have to improve it. And of course, the new system needs to be live last week. It had to be live last week. So you are already running late in the project. So start now. Okay, what do you do at this point? You look around, the old system is kind of like this. So it's not completely useless, okay? It had a good base, but it's in huge need of repairs at this point. So the first way is just work with it. So try to work inside that space. But as it happens, the current architecture is not very stable. And if you are going to build on it, it's going to be even more unstable. Then you see that developers take much longer than they should, building very simple features. Everything has to be changed in many places, and everything requires a lot of work. And workers, as they did in the bank, say that they feel like they are rowing in chewing gum. Okay, they row and they row, but it's all chewing gum, so they don't go forward. And this is the usual symptom that something is wrong in the system. Okay, so you think this is not going well. So let's see the second way. And the second way is to throw everything away and rewrite everything. This is a link to a very interesting article by Joel Spolsky on software, where he speaks about how Netscape spent 4 years rewriting Navigator, and in the end, nothing came out of it. And then many years later, they came out with Firefox, which was a new beginning, and it was lean, it was fast, and everything was much better. But then apparently they had wasted their initial lead, and now Microsoft Internet Explorer was everywhere. So you have to stop doing everything for whatever it takes to rewrite everything, 1 year, 2 years, and you are not going to do new work because you are going to be focused on the new system. And you have to trust that somehow the second system is going to be better. Okay, about stopping requirements, of course, you can also work in parallel in both systems, the old and the new, and that's what they did in the bank, in the mortgage system. But as we will see, then feature catch-up becomes completely untractable. And about the second time, anyone knows Fred Brooks here? He was the writer of the mythical Man Month. Nowadays it would be Person Month. The mythical Man Month spoke about how you allocate your resources in what at the point was man months or person months. Okay, one person, 1 month, and then managerial wisdom at the time said that if you wanted to have the system in half the time, you had to just double the number of people, so that the total in person months was the same. As you know, this is a big fallacy. But then he spoke also about other things, and one was the second system effect. And what he spoke about was that when architects designed the second system, they used to bring everything that they had left around the first time, and then what they got was a big pile of things, usually over-architected. So if you rewrite everything, you have the risk of running into this effect and then gathering a huge system that is over-engineered and bloated. Let's say, again, the mortgage workflow, more than 2 million euros, 25 people at the peak. And meanwhile, new requirements were being implemented in the old system. So at this point, what do? Do we implement everything also in the new system, increasing their workload? Do we just work on the first system and then stop requirements? In this particular example, we were just working on the new system, and the old system was being improved, and the new system was playing catch up all the time. So in fact, it was impossible, because once they arrived to the initial point, they would have to implement a backlog of 2 years of changes. And also, let's talk about the database. What we had originally was a database with about 100 tables, an Oracle database. So the architects said, let's do this right this time. Let's renormalize everything to third normal form, okay, which is a formal thing where nothing is repeated, everything is awesome. So the result was a monster with 400 tables. Everything was specified in a table somewhere, but it was completely impossible to move around and find what you wanted. This system, thankfully, never saw production, but it would have been a complete mess. I can tell you that. So those are our 2 ways. Is there a third way, like Sinatra would have said? Can we find some kind of middle ground? This is what we are going to talk about today. How to improve a system which is running at the moment. This is interesting because what we have to do is we have a lot of technical debt. So when you have a huge debt, what do? You pay it in small increments, but you pay it continuously, like a mortgage. Okay, so you took some debt, which allowed you to be faster at the moment, but then debt piles on and you need to pay it, or it's going to slow you down. So you use part of the team to repay the technical debt, while the rest is working on other things. Okay, we have the advantage in our business that, what we do is awesome. We can renovate the whole house while we live in it, without having to leave the house for a few months or years. No, we can do everything while we are in it. We can renovate everything and not be uncomfortable in the process. So let's talk about some techniques to get there, okay? Probably when you arrive at a system which is not up to par, one of the deficient things is going to be the test system. So what I would encourage you is to build a good test system. Of course, there's nothing. So what people usually tend to think is that it's impossible to work the test on a running system because it's going to be so much effort. Okay, So what I say is just start somewhere. And usually also unit tests, which are great when you are working on something, but are expendable at this point. Okay, so what you probably want is to do some kind of integration test of your backend code, to test some services in a row, and then you have something to start. For instance, usually with the usual management application, you can add things, you can remove things, list things, and modify things. So your basic test, for instance, you take an entity in your system, say customer, and you probably have a function for each of those. So take that is your first test case, and what you have to do is add a customer, then modify the customer, remove the customer, and check that everything works. Okay, that's very simple. That is going to allow you to do a diagonal test in your system and check that things are running. Okay, so just start somewhere. And then you can test the APIs from outside. So first you can test the controller, let's say, your calls, your function calls, and then you can test the APIs on the outside. And also you can test front-end code, okay, so that you verify that your page is working. But just start somewhere that makes sense to you and use that as a foundation. Of course, now you have to change your code, so refactor your code, improve upon it, and make small incremental changes all the time, which is the way to get to where you want. But the business people are going to be asking, hey, what about my requirements? I also want improvements. So what you can do is you intersperse technical improvements, architectural or infrastructure improvements with business improvements. You can have two teams in parallel, working in parallel if you have enough people, or just make people change and do some technical improvements and then some business requirements. And this will keep the business people happy and also the technical people happy. Just improve the system as you go along and leave code better than it was. When you arrive to a function to modify something, just improve the function, modernize it, and then do the changes that are required. This is going to allow you to have a much better system as you go along. A very important part of this is to lose the fear to make changes, because when you arrive, probably the developers are wary of making changes because they will notice that if they change anything, the system is prone to break. So they will probably limit their changes to very small improvements. They will be afraid of making big improvements. It's very important to allow the team to lose this fear. Okay, and you will hear things like, this was like this before I joined, I don't know who did it, or this must be here for some kind of reason, which I don't know. And the code is awful, yes, but there are reasons beyond our understanding. Here, I would say be pragmatic. Okay, and one very important point is to know what to do when something is not working. So I have worked with many people that say, no, if something is not working, what you have to do is understand it. And then once you understand it, you can improve on it. And to that, I say, be pragmatic, throw everything away if you need, and then rebuild it with a new code that works better. My experience, all the time that you spend understanding the old system is going to be thrown away because you are redoing that small part anyway. So the message is, instead of doing a big rewrite and changing everything, just go to the conflicted parts and rebuild those. Rebuild those modules part by part, and the result is going probably to amaze you. Okay, and simplify your architecture. What you have is probably a big pile of interconnected things. We're going to see an example later on. So just graph it, make a drawing, and reduce the number of moving parts, reduce the number of databases that you use, reduce the number of environments, and simplify it so that everyone can understand it. And remove any gears that don't run smoothly. Okay, you say this subsystem is a mess, so we are going to rewrite this particular thing, this service, this whatever. So in time, what you will see is that you are moving slowly, probably slower than you would like to, but surely, and you are going towards your objective. So what I would say is draw the path in your head where you are now and where you want to be, and then just check your progress along the line and check that you are moving towards your progress. And I don't know, probably you will never get to the end point, but as long as you are moving along, everything is cool, okay? Probably there are things that you thought about in the improvements that you thought about that you are never going to do, but that's fine, just improve your system. And as we saw before, business is going to need their improvements, so just keep doing them at the same time. Also, it's not good if you come as a divine architect and say, okay, I see it now, I see where we are going, we have to go there, and just tell the team what they have to do to get there. Okay. First, probably they have very good ideas too, so if you ask them, they know that there are pain points and they know what takes them time to do, so involving them is going to make you also learn a lot about the system. And they also will probably have a lot of good ideas. That's been my experience always. So if you involve them, they are going to embrace the changes with more enthusiasm than if you just pile them upon the team. And also, this is a very subtle point, but many people want to have a system that does everything all the time, and then whenever you come up with a bit of manual work, they will think this is not good. This is a very sloppy, you know. Everything should be automatic, but it's okay. I mean, manual work is okay as long as you are not expending an hour every day doing it. Some bits of manual work are fine. Instead of building a huge system which has 100 functions, maybe you can do with 20 functions and someone to do the manual work part-time. You know, you can involve business also. You can bring in some other people to help you. And of course, this is the most important part, disseminate the culture. If you want to teach people good practices, then teach the team. Show them how to do things with them, pair with them. Code review is going to be, can help you a lot, can be a very important part of culture. Because when you are reviewing code with people, you are telling them what you expect from them, and they will tell you what they expect from you. They will show you what they are capable of. So code reviews, in my experience, are very important. Here I will link an article that I wrote. I forgot here, sorry, but I can look for it right now. By the way, this is my homepage, and this is the article I'm talking about. Okay, about code reviews. If you want to learn more about the subject, about this, so code review can help you a lot. And when the team falls short, just show them how to do things, because they are probably coming from a very different culture from yours. So just tell them what you do and teach them. Not in vain, in martial arts movies, the expert is always called the master, you know. So be a master to your team. Teach them what they want to learn. I'm sure they are eager to learn new things. I mean, all of the teams that I worked with were eager to learn. Sorry about that. And when you are doing all of these things, it's not losing time. You are investing in your people, in your team, in your culture. So you should be able to sell this to the executive team just as an investment that they are making. Okay, now the part about tooling. When you are building, then you will probably need tools, new tools. So if you hire a DevOps person, they will probably say, okay, we need to install a Jenkins or whatever they like. Okay, tools are great, but it's very easy to misuse tools and to think that tools are the destination and not just part of the way. Okay, so this must always be kept in mind. Maybe you don't need to install a Jenkins. Maybe you can go along with a couple of bash scripts to deploy your code. Maybe not, I don't know, but just check it out. Maybe you can write a Python script, 200 lines that does most of what you need. Okay. Also, who should do the infrastructure work? This is not very glamorous work. It's working on tools, on platform, on frameworks. But in my experience, the most experienced developers should do it because they are the ones that know the needs and that can work better in this kind of thing. Tooling, of infrastructure, of frameworks. Also, even though the most experienced devs do it, just as always, you should involve the whole team so that they learn the tools, they learn how to do things, and they also can grow. Now, another chapter, which is about live migrations. Sorry, I didn't have much time to look for good jobs, for good jokes, so I just have a couple of lousy jokes like this one. So what we're going to do is to do a migration from, I don't know, one database to another one, from one architecture to another one. How do we do this in practice? So a few years ago, I came up with something which I call the fluid architecture. The name doesn't matter very much. It was just catchy and I liked it. But the idea is very simple, that what you need to do is to do incremental changes on your system and do them always in a reversible way. This will allow you to move seamlessly from one state to the next. And all of the changes should be done in small increments. This is the article that I wrote at the time in Spanish, and this is another one about reversible engineering, if you want to learn more about the subject. So, for instance, when you do backend changes, there are the usual operations, add things, remove things, modify things. So, you may feel the need to modify an existing service. Okay, don't do it. Just add a new service instead. The old one will keep running, and the new one is going to be able to be called in parallel. So when you add a service, everything is backward compatible, and you can deploy it whenever you want, and your deployments are going to be much simpler. Never modify services, and only delete the services once they are not in use any longer. So this is what you do in the backend. In the front end, what you do is change the call from the old service to the new one. Okay, once you have that, that can also be deployed to production seamlessly, reversible, completely reversible. And then once everything is in production, you can make the irreversible change, which is delete the old service. Okay. This is, in essence, the strategy to do, okay, to work. Front-end changes should be, as we have seen, atomic. Instead of calling this service, call the new one. Everything is, again, forward compatible, and it can be reversed without any ill effects. Now let's see a little bit about database migrations. Okay, this means we have a database and then we want to migrate it. In these cases where NoSQL databases shine. Why? Because they usually don't have a fixed schema like MongoDB, so you don't need to make the schema change. You just run some kind of script on the database, modify it if needed, and then start the new code. For instance, let's say you need to rename an attribute. What do? Just run a script that creates the new attribute without modifying the old one. Okay, we add the new attribute and then we can use it and everything is backward compatible. Of course, if you don't need to do the migration, it's even bit better. If your code can understand both the old data and the new data, you don't need to do the migration. And everything should, as always, be backward compatible. This is an article in Spanish about migration strategies in case you want to learn more. And now let's see a little bit about our practical case, which is the company I'm working at currently. I joined in March. This is my awesome team. And what we are doing is, as I said, we sell software that helps sell things to influencers. So initially, what we had was kind of a hard system where deployments had to be done. They were very large, stop the world deployments. So everything had to be, the system had to be taken down, then the changes were done, backend changes, front-end changes, migrations, and then we had to test that everything was fine, and then we brought it back up. It was a very lengthy process, and it was a very labor-intensive process. Data migrations were quite painful because we had to stop everything. And so what do we do? The first thing that we did was to graph the architecture. This is the number of servers that we had, the number of environments, and the number of machines and connections, so that we knew everything that was there. And also another very important thing was the database. This slide here, this picture here, is the current state of the database when I joined. I graphed it completely, all of the entities and all of the lines. And this was what resulted. So what I did was kind of graph the path that we're going to go along. This was an improvement on the initial database schema, which was simpler and better, with less interconnections and better structured a little bit, okay? And this is where we wanted to arrive at eventually. Probably we are never going to get there because new requirements will appear along the way, but this is the objective, okay? So what did we need at that point? We needed some kind of deployment tool, okay? An integration tool that could download the code onto an integration environment, then run some kind of tests, and if possible, then deploy the code. And what we did, instead of installing in Jenkins or Jenkins X or whatever was fashionable, was build a very stupid tool, which was, I don't know, 200 lines of Node.js code at the moment. That time, now it's about 300 lines or so. And it has a very cool integration with GitHub so that it shows the green mark. Here you can see it. With each pull request, it shows the green mark if tests have passed. So it's able to test any branch in any of our projects and then show the results here, okay, by commits. As you see, here we have a pull request. These commits were not pushed, but the moment that it was pushed is here. Tests were broken, and then when tests pass, you know that it's now ready to be deployed. Okay, and then the tool, when you push to master, it's able to deploy to, in this case, to integration. Okay, we are still not at continuous deployment, which would mean that things go straight to production. I'm not sure if we are going ever to be there, but that's the objective. Okay. So we needed tests. So we built not one, but 3 test systems. The last one will surprise you. First, in the backend, we did some tests that run on the controllers. So instead of running on the API, externally, what we do is white box testing. We test each controller, we instantiate it. Allow me to, I'm in Vienna, by the way, so that's why it's already dark here. It grows dark very early here. So our first test system tests instantiates and tests the controllers of our services. So the second one is on the front end, and this is a bit more involved. What we have here is a system that brings up a test browser. It's a Cypress. It's called Cypress, the test framework. It brings up a browser, then it fires events on the browser, and it calls our code. This test is very interesting, this kind of test, because it not only tests page structure, but also the underlying backend services. So we are currently building this one, but it's already operational, so that just as we saw in the backend, now every front-end pull request is tested. Every commit, single commit, is tested now. And the last test system will surprise you, it's manual tests. As we saw, it's not good to be afraid of manual work at some point. So even though we know that this should be automated, we are not yet there. So what we are doing is running a battery of manual tests. One of the accounts people are helping us. So we also do the test sometimes, part of the team, but usually it's someone from accounts. They help us a lot and they run the manual tests. And this allows us to be more or less confident that nothing has broken. You know, they are mostly regression tests. So if you are still not at the point where you can automate everything, just run it manually, no problem. And this will help you a lot because the manual tests as a backup are always useful. You know, having manual tools to do things is always useful. Even if you have an automatic tool, having the manual tool to do things if the automated tool breaks down is always very useful. So it's now 7 months later after I joined the company. So where are we now? We do deployments every other week. Of course, the target is much more ambitious, but at this point we are doing deployments once every 1 or 2 weeks. We have rebuilt half the platform at this point, so we are much more confident that things are not going to break down. And we have improved everything. Now developers, I would say, that are not afraid to touch anything. So we have redone large chunks of front-end code, large chunks of back-end code. We had a microservice architecture at the beginning, which was not very useful. It was just making noise for us, adding noise to the process for us. So we have actually removed it, and now we have a monolith, but it's a quite small system, and it doesn't have any needs for separate deployments or performance or scalability. It was not really useful, so we have removed that. In the future, we may want to implement a microservice architecture, maybe, but it will be a different architecture than the one that was already there. Our final target would be to arrive to a state where we can do continuous deployment and have, I don't know, 5-10 deployments per day. That's what we had at a previous job that we were in. We did around 5 deployments per day, and everything was working awesome. And also complete the front-end tests so that we can run the whole suite with every commit. So now let's talk a little bit about conclusions that we have extracted from this presentation, hopefully. First is that you always need to work with your team because they are your biggest strength. You cannot do everything on your own unless it's a very small company. If it's a small company, then fine, you have no team, you're alone, you do everything. This point is not valid. In any other case, your team is going to be your biggest strength, and they are going to help you along the process if you let them. I'm not just saying this because one of my team members is listening. Hello, Bea. But It's also a point. Another conclusion is to always work preserving backward compatibility. If you keep to this golden rule, everything is going to be much easier. Bear says hello. So just do everything in this fashion, either a database migration, either a code migration, system migration. When we removed the microservice architecture, what we did was replicate everything in the monolith, okay? And we did not modify the code at the same point. We got the microservices, got all of them, put them inside the monolith, which was a backward compatible change, and then we change the invocations from the microservice to the internal service, which is also backward compatible, and then we deployed that. And then later, at some point in the future, we haven't even removed many of the old microservices. They are still there. They don't ask us for money, so they can live there. And once you find that they are not in use, you can remove them at your leisure. And always do the migrations in a reversible fashion. Okay, always make sure that you can go to the previous step without having to do manual changes, that everything works in this fashion. As long as you keep doing things this way, everything is going to be much easier. Okay, so thank you very much for coming to this webinar. This is the Dancing Nun that always puts a smile on people's faces, and this on mine. So I'm not sure how this works now, but you can make questions if you want. So I guess in the chat here. Let's try if some questions come along. Maybe speaking, you can try to speak, I'm not sure. Domitila, can you help us? Maybe there are no questions, I'm not sure. Okay, I can read the question in the tab question. Let's see, but there are no questions, okay. So just a minute in case someone is writing. Oh, great, I have it here. I have the tabs here. So feel free to make any questions about the bank, about our current infrastructure, about migrations, about refactoring, about architecture. Okay, apparently I have answered the doubts of Patricia. So thank you very much, Patricia. And if you want anything in the future, just come along to my Twitter, to Pinchito here, if you want, and ask me whatever, okay? Any approach to follow? Good question. So what you would like is to practice this. What I would say is just to encourage you to build a system with one database, and then you are probably going to find shortcomings with that database. Just try to migrate to a new database, okay? And then try to put in practice the principles of reversible, doing everything reversibly, or backward compatibility. Okay, and keeping your system running at all times. Instead of just doing the easy thing, which is stop the old database, migrate to the new database, and then start it up again, just try to do it while everything is running. And this is going to be a very good exercise, I think. Let's say you are wondering what database should I use? Either Oracle, MySQL, PostgreSQL, MongoDB, whatever. So pick one of them, do the same thing in what I would say is just run a small prototype with each of them, okay? and then find out which is best suited for you. And you can even go from one to the next with a live migration, okay, instead of taking everything down. I would love to provide more case studies, but what I have found is that there's not much literature about database migrations. And for me, it's a very interesting aspect because I have done a lot of migrations at my previous company. And here we have done a lot of data migrations here at Infinity. We have done a couple of, well, rather a couple at this point, but there's not much literature about it. So if you find any good references, just send them my way. I think that in the article about the fluid architecture, let me check. Here in migration strategies, you have the strategies, but unluckily they are only in English. Okay, so I don't know, if there's interest, I can translate this page. Okay. So thanks, Pepe, for your question. Thanks also, Praveen and Patricia. Oh, there are more. Cool. How do you add tests? Well, as I said, the best thing is to just start somewhere. And what I would recommend is, instead of building unit tests, is build some kind of integration test like that. Add some entity, modify it, and remove it. A very simple test. And this is going to allow you to have confidence in the system and also in your ability to build tests. Okay, so that's where I would start, in a kind of diagonal test. Instead of testing every functionality, just test one at a time. Okay, Patricia. And Bogdan is asking for a place to see the recorded version. Yes, I will also tweet it once the organizers pass it along. And if you follow the Codemotion page, it's probably going to be published there also. Okay. So Praveen, thank you very much. And we are right on time, I think, 13 minutes. So thank you very much for your time. I should perhaps write the answers here. I will write them presently. And see you next time. Bye-bye.